Here I am, 40 kilometers away from my home in a different country to test out the antenna that I made. Hi everyone and welcome back to my workshop. In the video that you see there on the screen, I was testing an omnidirectional LoRa antenna to get to distances of up to 20 kilometers. And I'm going to link that video up here, but that left me intrigued to try and go even further. So I'm gonna build a directional antenna that I'll have to go to a different country to test it out. So stick till the end to see the results. But first, let's build it. To construct this antenna, here is the parts that we're gonna need. First off, we're gonna need the lead that will come out from the antenna and connect to the LoRa board that we're gonna use. So I used a cable that I had laying around with an SMA connector because that's what we have on the module. I cut it off and strip out the two wires. This is a coaxial cable, so there's shielding on the outside and the signal wire on the inside. That's ready. We have this, which is a two-part assembly of 3D printed parts. Below we have the handle, and on this long piece we have the boom of the antenna with the positions for each of the metal rods that we're gonna add from the copper rods. In the middle I left a small gap, so because of the driven element needs to be split in the middle, we're gonna be able to see the gap and make sure that we have enough gap. Then I have a hole where I could route the wire through and connect to those two elements, and the three other parts will be up in the front. This is just structural, so all of the holes are just to save filaments, and we have this nice end light. I'm gonna have links to the STL file down in the video description if you have a 3D printer to print it out. If not, then our friends at PCBWay can help, because you can send them the model and they'll print it out for you. And not only that, PCBWay can also help you with anything for your project. They offer services for PCB manufacturing, CNC machining, metal fabrication, as well as 3D printing. So no matter your project needs, they are here to help. Use their online ordering form to get instant quotes for any of their offered materials. And if you ever need help, their support team is always ready to jump in and provide the best service possible. If you are new to PCB design and you're still learning, PCBWay offers a shared project section that can be a great starting point for you to find something from the community that you can make for yourself or that can serve as inspiration for your next build. And if you already have a project in mind, but you're looking for parts and sensors, their module store offers a great variety of parts to choose from. All in all, PCBWay is your one-stop shop for all of your manufacturing and project needs. So visit the link in the video description to get your welcome bonus and start working on your next project. So to construct the antenna, the idea is that we're gonna use the copper rods to slide into the 3D printed holder, and it's important to have the holes at the right dimension, because that's how this whole antenna works. The last piece is what it's called the reflector. Then in front of that we're gonna have the driven element that we're gonna connect the cable to, and on the front of that are the three directors, and the dimensions and everything for the antenna I got from a website called 3G Aerial, and I'm gonna have the link down in the video description. They have this script that you tell it the frequency that you want the antenna to work on. You specify some of the elements that you have, like the diameter of the copper wire that I have is 2 millimeters, so that's the full diameter, not the cross section. And I wanted the boom to be 10 millimeters square with a total of 5 elements. That gave us that the antenna should hopefully have a gain of 10 dBi, which should dramatically increase the output and the distance that we can talk. But most importantly, it gives us the dimensions of all of the elements. So the reflector will be at position 0 with a length of 168 millimeters. And I cut the copper at exactly 168 millimeters, trying to be as precise as possible. So that's that, 168. Then we have the dipole, which is the driven element, at 159 millimeters, but that needs to be cut in half So, and we're gonna need to have a gap smaller than 4.6 millimeters at the center. Next is the directors D1, D2, and D3. Those are the ones in the front. The first one is with length of 151 millimeters, then 149, and the final will be 147. Depending on the frequency and the dimensions of the elements that you have, the script will give you probably different results. And I'm by no means an expert, so I don't know if they're gonna work or not, but that's the whole point of this experiment, that we're gonna try it out and see for ourselves if it works or not. Now, to be able to properly position the rods in the center of the boom, I've marked out the center 10 centimeters by measuring the whole length, subtracting 10, and then splitting that into 2. So I did the 2 marks, and hopefully when I slide it inside the hole, then I can align it just right where it sits on the center, because that is important to have the 2 distances correctly in place. I had to drill, I left the holes during print a bit too small, so I had to re-drill them with a drill bit, and now the wire is loose, so I'm gonna use a drop of CA glue to secure them. So let's see how that goes. And I don't want to get any on the hinge, so let's see how that works. Okay, in theory that should now be centered. I can't really see the marks that I make. Okay, let's double check. Okay, that should be about right at 79 millimeters. And the problem is that because of my size of 3D printer, I couldn't leave the boom to be bigger this way, because it was at the limit of what I could print. So the hinge is a bit too close to the reflector in the back, but hopefully it should be okay. Okay, that was a bit difficult to align properly, so I'll need to maybe figure out a better strategy. This here is the driven element, so the dipole, and then as we progress, each next element is a bit shorter than the last. So I'm gonna skip the dipole now, so I'm gonna add the middle element. Yeah, as soon as I go, the marks that I made get erased, so I need to be quick and precise on the first try. Okay. That feels about right. We have 70 and we have 70 here. So 69. I probably drilled this hole a bit out of center, but I think we can adjust it later on. And the last one at the front. There's a piece of plastic that's blocking the hole. Okay, that is now in. Let's add a bit of glue. Okay, now let's start and work on the driven element. Okay, so that is about 159 millimeters, and the half of it is 79.5. So I'm gonna just add a mark here. The gap that I have in the middle of this is about 4 millimeters, so that's under 4.6, but I'm gonna try and just remove 2 millimeters, so maybe 1.5 on each side, so 1.5 there and 1.5 there, so we have 2 equal elements. And the way to cut this, because when you cut it, the cutter will leave a mark, so I'm using this flush cutter. So whenever you try to cut the wire, you're gonna have this sort of finish on it on the side that it has the cutters on. But if I then cut it once again, and I'm keeping the finger so it doesn't fly off, then what I'm left off is the straight cut that I'm gonna need. So we will need to cut this piece twice, and I'm gonna cut it once like this. That's one piece, and you see we have the pointy edge here, if it focuses, and I'm gonna cut once again. So we have 2 pieces. Hopefully they should be identical, almost. Let's cut that bit off if we can. Okay, so they are both identical, and we're gonna slide them one on each side, but first we need to figure out how we're gonna electrically connect the antenna. What I decided on is to use terminals like this, that I strip the plastic off and I screw them close to the end, so when I put them into the hole, that it just protrudes slightly inside. And I did the same on the other side, and knowing that this gap is 4 millimeters, I can be sure that that gap inside is less than 4.5 millimeters, and I'm just gonna glue this like this. And on the other side we can use the other screw to slide in the wire and then secure it to make electrical contact. Now let's try to first glue them one by one on each side. See how that goes. I'm gonna add glue to the hole and be generous with it. Okay, let's give it a second so it solidifies. Gluing copper is actually quick, because there's a video recently that Veritasium did about how super glue works. I'm gonna link up here in the corner so you can check it out. Okay, and let's do the same on the other side. We want to make sure that the strips are parallel with the rest, which they seem to be. Okay, and I'm gonna actually add some more glue to the side so we have more mechanical strength, and I'm gonna add it to the screws as well here, so we know that they are secured. Okay, so I think that that's dry enough. Now let's try to add the cable, and I'm gonna slide the cable. I didn't know the orientation that I'm gonna end up with, so I left holes on 2 of the sides. Let's trim this a bit. So I'm gonna run the wire through both of those. Let's figure out how we're gonna connect. And another thing is that I'm not really sure which one should be the positive or which one should be the negative, or if that really has any change, because at the field I can flip it and then that would flip the polarity basically. So I'm gonna just connect them at random. I wasn't really able to find any appropriate information online, and I'm quite new with antennas, so if you know, feel free to fill in any voids in the video comments. Okay, so the center wire I think will be relatively straightforward. I'm just trying to cram it in. Not really working as I expected. Let's try and cram that in. Okay, so that's definitely not working as expected. Let's try and shorten it a bit. And this time I'm gonna try to have the strands just open. And let's try and clean up some of the strands that stayed inside. Maybe it's a good idea to solder this on. Yeah, this works much nicer now. Okay, let's add the screw back on. So I'm trying to have it in front of the screw. And then just press it in. Nope, that didn't work. Maybe we just solder it. Let's try that. Okay, so I'm gonna start by trying to solder the stranded wire first. Let's see if it's gonna accept solder and how well. Hopefully it doesn't break the plastic. I'm gonna try to increase the temperature. I'm at 480 degrees now. I was at 380 before. I mean, it looks soldered, but I'm not really seeing it flowing that well, at least not on the wire. Yep, it doesn't seem to be soldered. Okay, now it is. Now it's definitely soldered, so I'm gonna try and add some solder first to both the wire. Okay. And to the copper wire here. Okay, that's on there. And that's definitely there, but as I suspected, we kind of melted the plastic, so I'm gonna try to be as gentle as possible until it gets cold again. That doesn't look too bad. I need to figure out a way how to add some strain relief, so I'm thinking to zip tie this here. Okay, and then I'm gonna add one more zip tie to the cable itself, so that there's some resistance in trying to pull the wire out. Okay, I'm gonna push it in up slightly. Attach that to the cable, nice and tight. Okay, and we can now cut this off. I think that looks okay. Let's double check that we have at least not connected those two together in any way. So continuity check. That seems fine. Let's try and do a continuity check on the cable. So first the outside. Yep, that is electrically connected. And now let's try the inside. Yep, I think that's it. Okay, so now before we go out in the field and test this whole setup out, let me tell you how it's gonna work. So this is the base station, and it using the smallest of the Reyax modules, which is the Reyax RYLR998, and this is the one that I currently have connected on the computer, and this is what's gonna stay at home with its onboard antenna. And this is how I did the test previously, and this is the remote setup that we're gonna have. I have it connected to the antenna that I made, and if I press the flash button on the microcontroller here, you're gonna see here to the terminal that we're gonna send a message to that module. That module, when it receives it, it's gonna send it back, and we're gonna get that message ping back. So whatever we send out, that's what we're gonna get. And you could see there at the end, I'm gonna have the recording from this on screen. You're gonna see there that we have a count variable that we increase on each send. So if I press flash once again, now the count will be 5. It's gonna send out, come back, and it's gonna light up the LED when it does. If we reset the module, let's see now, if we try to send, then we're gonna send message of count 0, and we're gonna get message of count 0. Just to show you that that still works, if I turn off the base station, so technically now it's out of reach, when I press the flash button, now we're gonna send the message, but we will not receive any pin back. So we will not receive the message pin back, whatever we send, and the count will increase on each send, but we will not get any response. If we, however, manage to establish connection with the base station, so I now turned it on once again, and I try to send count 3, hopefully. Okay, something's wrong. Okay, so it turned out in that previous example I didn't have the band set correctly on the receiving module, so after it got reset, it got reverted back to 915 megahertz, which is the US standard. I'm based in Europe, and this one is working on 868 megahertz, and this is what the antenna is made for. So if we try that again, I'm gonna reset this device, and I'm also gonna reset this device. So technically both counts on the devices should be 0, and if we try to send now with count 0, we're gonna get the pin back that it's count 0. Then we're gonna send count 1, so that receives us the ping back of count 1. Now if we disconnect the device, so we no longer have the station receiving, if we try to send count 2, so we get the message but there is no ping back, meaning that we are not communicating with the station. And if I do it once again, so count 3, nothing, meaning we don't really have communication, and we can try to do this as many times as we want, but it will not work unless we have the station back in range. So if I now send the message, count 5, we should get the ping back. So we get the count 5 ping back, so we know that this is the exact message that we sent and we got back from the module. And with that, I think we're done at the workbench, and next step would be to go out in the field and see what kind of distances we're gonna get with the antenna. Okay, so before I head out, here is where the station will be placed. This is on my balcony, and I'm gonna do a sanity check because where I'm planning to go is about 40 kilometers in that way, but I'm gonna go first about 8 kilometers on this side where I did the first experiment and try it just to confirm that it at least works. Okay, so I'm at location, currently about 8 kilometers away. About 8 kilometers away from the station, and so far from the car we've been testing this. I have my daughter here helping. I'm gonna have a screen recording of this, so let's try and press the flash button. And we got the message ping back, and the antenna is not even pointing in the right direction. So let's try and switch it to some other direction and see if that direction matters. Okay, let's try and press the flash again. Check. Okay, count 5, and we got the ping back, and now the antenna is just pointing away. Maybe let's try completely away. Okay, that doesn't seem to work. So there is some directionality to the antenna because now it's pointing away. You could see the power plant there, and we did not get the ping back. Right, let's try again. Count 7, count 8, no ping back. Okay, so in the direction, and we got the ping back. Okay, so now we head out to the destination that we had planned in the first place, because in this direction we can only get to about 20 kilometers, and that we saw that it already works with the old antenna.
The next day.
Well, that's definitely not the weather that I hope for, but the station is ready and I'm ready to head out that way. Okay, so we're at location that is about 40 kilometers from where we put the station. This is the antenna, and we're gonna point it in that direction over there. Moment of truth. Please work. Hold on, we don't have it connected. Yep, it does work. Let's try that once again. Oh yeah, we got the communication. How cool is that? That's 40 kilometers away. And to also test out the antenna that we used the last time, remember with this one we managed to get up to about 20 kilometers when we were doing the initial testing. Now we're at the same location where we worked with the other antenna. Let's try it out. Oh, that one still works. That's amazing. Oh my god. Even with this antenna, it still works at 40 kilometers away. Now, you know how important it is that you have clear line of sight, and this proves it. Because in the previous test we didn't have a clear line of sight, so it was a bit difficult to get communication beyond 20 kilometers. And now it works with the same antenna on 40 again. Not always. Just to prove that it wasn't a fluke, here's the DIY antenna once again, and I'm pointing it in the right direction, and it works basically every time. Let's try now, and we'll point it away, and it didn't. So I have it pointed away, and it doesn't work. But if I point it in the direction of the receiver, it now works. And with that, I'm gonna declare this experiment as a success. It was really fun to go out and see what an antenna that we did relatively easy can do. I was quite surprised with the omnidirectional antenna, because even that one was able to pick up at least few of the communications and got some of the replies. It wasn't really reliable, so I had to make sure that it's at the right angle, but the directional one was just straight working without any lost packages and without any issues in communication. And also keep in mind that on the other hand, we had this tiny omnidirectional antenna. At the moment, I don't have the necessary technical knowledge to be able to define the specs of the antenna, but it seems that the website that we use to generate the distances and the length of the antenna elements seems to do it a good job. I'll have links to the files and to the specification in the video description, so feel free to make your own version. And if you have the knowledge, please test out the antenna and let me know if it's within specs and if it's a good choice. It seems to be working quite well, at least to the distance that I was able to test it. As I said, everything will be linked down below in the video description. Make sure to subscribe so you don't miss any of the future videos that I do. If you have any questions, leave them down in the video comments, and I would see you all in the next one. Cheers!